Today, students, let us learn about number system. You would have learned in your previous grades numbers, different type of numbers. Till 8th grade, you have done rational numbers. Like first number that you learned is natural numbers. What are natural numbers? Numbers that starts from 1 and goes till infinity. You have learned whole numbers, numbers that start from 0 and then again goes to infinity. Then you learned integers. Integers are both negative and positive numbers, including 0. They starts from negative infinity, then comes in between 0 and then goes to positive infinity. So they are like that. They do not really start from any number because it's negative infinity. The number line goes over here like that. If you remember, you would have done number line also. So you have 0. To the right of 0, you have all the positive numbers. And to the left of 0, you have all the negative numbers. Then you learnt rational numbers. You learnt rational numbers. What exactly are rational numbers, if you all remember? A number of the form of p by q, where p and q are integers and q cannot be equals to 0. Any number of the form of p by q where p and q are integers and q is not 0 is a rational number. So now my rational number can be minus 1 by 2, 7 by 8. They are all rational numbers. Negative rational number, positive rational number. This is all about rational number. Now, one new thing that you are going to learn over here in the ninth grade is irrational numbers. What you are going to learn about here is irrational numbers. Now, what are these irrational numbers? You have learned square roots, cube roots in 8th grade. So, square root of 2, square root of 3, root of 5, root of 7. All these numbers are called irrational numbers. These type of numbers, we call them as radicals, we call them as surds, which have powers in fractions. So they are termed as, because 2 root of 2 can be written as power of 1 by 2. Root of 3 is also power of 1 by 2. If I write cube root of 2, it is 2 to the power 1 by 3. So these type of numbers are called as irrational numbers. Square root of any number is irrational numbers. Now let us see, all together these numbers are called what? I talked about natural numbers, rational numbers, whole numbers, integers, irrational. All these numbers are termed as real numbers. They are called as real numbers. Real numbers are rational numbers, real numbers, irrational numbers. Now, irrational numbers, the powers one, which root 2, root 3, all those things, they are those. Now, rational numbers, if I say, it includes everything, your natural numbers, your whole numbers, integers, fractional form, in the form of fractions, they are all rational numbers only. Now, how do we differentiate between rational and irrational? There is one more thing. If I talk about a rational number 1 by 2, 1 by 2, you know, can be written in decimal form as 0.5. If I take 1.5, that is also 0.2. Now let's take 1 by 3. Let's take 1 by 3. What is a decimal expansion of 1 by 3? If you try dividing the numerator by the denominator, 1 is smaller than that, so I'll put a decimal, 0 will come. 3 threes are 9. Subtract, again 1 will come. Again I'll put 0. Again I'll go by 3. Then I'll get 9 minus 1. put 0 again, again 3, 9 minus 1. So if you see, this will keep on going. This thing will keep on going. It's a never ending division, never ending. You would have come across this type of division when you convert fractions into decimal numbers. We are doing what? We are converting fractions into decimal numbers. So when you get this type of decimal expansion, it is coming as 0.3333, keep on going. So it is repeating. What we term it as, it is repeating or it is non-terminating. So this type of decimal expansion is called as what? So decimal expansion. This is known as repeating, or it is also non-terminating. Not or, I'll say both. Repeating and non-terminating over here. This one that I wrote, it is a terminating. Terminating decimal expansion. This is repeating, non-terminating. As 3 is repeating, this pattern is coming on again and again. So I can, as only 3 is repeating, I'll put a bar on top of that. So 1 by 3 can be represented as 0.3 bar. Let's take one more example. Let's take 2 divided by 11. Let's convert this into decimal expansion. How do? We take numerator in as the dividend and 11 is the divisor. So again it is not going, so I'll put 0 decimal, so 0 will come over here. So 11 ones are 11. I'll get 9 after subtraction, decimal is there, so put 0. So we'll go by 8, 18. So 8, so 11 eights are 88, subtract, you will get again 2 over here, then put 0, then again it will go by 1. I'll get again 11 minus 9, again put 0. So again it will go by 8. You will again get 88 minus. Now if you see, again 2 came. So the same step will repeat. So what you will get over here? Again you will get 1 8, same way. So this is becoming what? 0.181818 and going on. So I can write it as both 1 8 are repeating. I'll put a bar on top of that. So again I got a what type of decimal expansion? This is called as non-terminating repeating decimal. Non-terminating repeating decimal. So rational numbers we observe that have two type of decimal expansion. One is the terminating one. We can take for terminating one more example. Let's say if I have not one we have already taken many times. Let's take another example, 2 by 5. So if it is 2 by 5, what will I get over here? Let's divide 2 by 5. You just have to put 0. So 5 fours are 20. So that's 0.4. There is nothing repeating. It's finished. The division is completed. So it is a terminating decimal expansion. Now let us see about irrational numbers. What type of decimal expansion they have. So if you know, let's take, you people remember how to take out the square roots. Let's go back to the place where we have the rational numbers only. Okay, over here we have, no, where was it? Let me just, yeah, over here we had that thing. So let's start with root 2 if you remember. So root 2, how to get the square root of root 2? You can find it using long division. So 2. 2 is the only number over here, so I have to put a not decimal over here first. 2, the what is the perfect square number less than 2? That is 1. So 1 ones are 1. Subtract, you will get 1. Now nothing is there, so I have to put a decimal. When you put a decimal, you will get pairs of zeros. You can add. So let's bring down this pair of 0. Double of the quotient is 2. Now for 2, I can go by 4 will work over here. 4 fours are 24 fours are, so it will be 6, 1 carry over here. So 96 minus, I get 4. Again, I'll bring down the zeros. Double of 14 is 28. Yeah. So 28 is there. I think it will go by 1 only, because if I take it 2, it will be a bigger number than 400. So 1. So 281 only will come, and I subtract. I'll get what? 10 minus 1 is 9. 9 minus 8 is 1, and 3 minus 2 is 1. And I'll bring down this thing over here, 0, 0. Now 141, double will be what? 282 will come over here. Now 282, so what can come over here? So any number that will work over here. 8 won't work because 8 twos are 16. Let's check with that. 7 also no. 5 also won't work because 5 eights are 40, so will be a 4 carryover. Let's go for 4. 4 eights are, I think that can work over here. If I try with 4, 4 fours are 16, 1 carryover. 4 I'll write here. So 4 twos are 8 plus 1 9. 4 eights are 32, 3 1 1. Yeah, this works. When I subtract, I'll get 4 0. 8 minus 2 7. It will keep on going like that. So it is also keep on going. But if you see over here, the pattern is not repeating. You will get something different. It is also non-terminating, but it is not at all repeating. So what I got root 2 as over here is, so root 2 is coming as 1.414, and it's keep on going. There is no pattern being repeated. So it is also non-terminating, non-repeating decimal expansion. So for irrational number, the decimal expansion is non-terminating, non-repeating. Clear? Now let's take one more example in a bigger place, so that let's talk about root 3. Let's take the decimal expansion of root 3, and I'll do it over here. So 3. I'll start with 3. 3 is not a perfect square. Below 3, the perfect square is again 1 only. So 1 ones are 1. Subtract, you will get 2. Now I'll put decimal and I'll put pairs of zeros. Let's go to 4 places to check whether anything is repeating or no. So 1 double is 2 over here. I'll bring down 200. So now it will go by what number? Should I take it 4, 5? No, 6, 7, 8. Will 8 work over here? I think 8 will not work over here because we will get a bigger number. 7 and 7, if I try, 7 sevens are 49, 4 carry over, 1, 8. I think that will work, because if I try with 8, 8 8 are 64, 6, so that will be a bigger number. So minus it here. 10 minus 9, 1. 9 minus 8, 1. 11 comes out. Now bring down this whole pair, 0 0. Double of 17 is 34. Can we try with 3? 4 will be a bigger number, so let's try with 3. 3 threes are 9. 3 fours are 12. 1 carry over, 3 3 10. So minus it. 10 minus 9 is 1. 9 minus 2 7, and that's it. Bring down both the zeros now over here. There's a problem in the board. It's just okay. Now bring down this. So it comes over here. Double of 173 will be 6 4 1 246. Now we just do, whenever we have to come over here, we just double this thing. Okay, so is this a correct thing? Double of 173. Yeah, I think that's a, no, that's not correct. Let me just erase it. It has to be 346. It has to be 346. Now let's multiply it with its 3. So 2 should work over here. Let's try with 2. 2 and 2. 2 twos are 4. 2 six are 12. 1 carry over 9. And then 2 threes are 6. Minus. So 10 minus 4 is 6. 9 minus 2 is 7. And 10 minus 9 is 1. So we got it over here. Now I'll bring down the other zeros, two zeros, and double the quotient again. So what will I get over here if I double it? 4, 3 plus 3, 6, 7, 7, 14, 1 carry over. So that will be 3, 4, 6, 4. Now what number should I multiply it with? I think 3. 4 can also work over here. 5 if I try. No, that will be a little bigger. So 4 if I try over here. 4. So 4 fours are 16. 1 carry over. 4 fours are 16 plus 1 17, 1 carry over, 4 6 are 24 plus 1 5, 2 carry over, 16 plus 2, that comes out to be 18, 1 carry over, 1 3. No, it's coming a bigger number. Let me just multiply it again. It is coming out to be a bigger number, yeah, because if I go it by 1 also, it is coming a bigger number, yeah. So let me just put it a 0 over here. That was a mistake. I have to go it by 0 because this is a bigger number. It's a smaller number. Only 176 is there, 0, 0. So I have to keep it 0. So it is coming out to be 0 only. And then again 17600 and 0, 0. More 0 I have to put and bring it down. So now what I got over here is one more 0 to be added, and it is going on. So what is root 3 value coming out to be? 1.7320, still going on. Sorry. So it will keep on going. It means that it is also of what form? There is no repetition over here. All numbers are different. So it is non-terminating, non-repeating decimal expansion for irrational number. So from here we came to a point that rational number has, all rational numbers have either they have terminating decimal expansion, or they have, if non-terminating, it is a repeating decimal expansion. It is a repeating decimal expansion. If we talk about irrational numbers, they have non-terminating and non-repeating decimal expansion. I hope this concept of terminating and non-terminating decimal expansion is clear to you all, because it is very important. There are questions which are based on this. So this repeating term I can also use, instead of repeating we can also use over here recurring, reoccur. It's recurring, or you can also use repeating instead of this repeating, non-repeating. So recurring and non-recurring, that's the decimal expansion for rational and irrational numbers. Now let's talk about few things. If I say that every natural number, if I say that every natural number is a real number, is this statement true? This is a true statement, yes, because every natural number can be represented is a real number only. I said that it is there. If I say that every natural number is a whole number, this is also true. It's also a true statement. But if I say that every rational number, every rational number is a natural number. So is this statement true or false? This will be counted as a false statement, because rational number can be 6 by 7, rational number can be minus 2 by 3. That is not a natural number. So it's a wrong statement. So whenever these type of statements comes and they have been asked that you have to represent it as a true or false, just take examples and decide whether it will be a true statement or a false statement. Now let's move to another thing, which is inserting a number. Inserting a number between rational numbers. You have done it in your 8th grade. You have done it in your 7th grade also, if I remember. Let's say if I give you two rational numbers, 2 and 3. It's very easy to insert a rational number between them. 2 and 3. The rational number can be in decimal form also. 2.5 will be definitely in between them. So you can write it as 25 by 10, which is what? 5 by 2. 5 by 2 is between them, 2.5 basically. Yeah. So it's a rational number between these two. There are steps to do that. What is that step? In between two rational numbers, how can you find a single rational number? So what you do is you add the two numbers, divide by 2. You will get 5 by 2. So any rational number exactly in between them is the average of that. So I got 5 by 2 in between these 2 and 3. Now if I say find a rational number between 2 and 5 by 2. So what I'll do is 2 plus 5 by 2 divided by 2. I find the mean of that. So what will it come out to be? You take LCM over here. So I'll write it as 1. So you have to multiply by 2. So it will become 4. 4 plus 5 by 2, which will change to what? 9 by 2 into 2, which is 9 by 4. Another rational number comes over here. So what I got over here, I'll write it like this. So in between 2, 5 by 2, 3. I got one more, 9 by 4. Now let's find between 5 by 2 and 3. Same way I'll proceed. 5 by 2 plus 3 by 2. So it will change to what? 2 3s are 6. So 5 plus 6. This 2 will be multiplied by this 2. So 2 2s are 4. So it's 11 by 4. Another rational number between them. So you can find any number of rational numbers in between two numbers by taking two numbers, finding the mean or average of the two, then taking the intermediate number and the corner number and finding the average of the two, and you can find it. Another shortcut way that you learned in your previous grade is, let's say you have two numbers 2 and 3. Okay, so you write them as fractions, 2 by 1, 3 by 1. They are like fractions, but still you need to, let's say I say find out two rational numbers between them. Two rational numbers you have to find out between them. So if you have to find out 2, make the denominator 3, one bigger than that. Okay, if you have to find out 2, make the denominator one bigger than that, so it is 1 only. So what I'll do, I'll multiply this by 3, this also by 3, multiply this by 3, this also by 3. So what you got over here, it is 6 by 3, this is 9 by 3. So you have more here, 7 by 3, you have 8 by 3. You got two numbers in between 2 and 3. Fine. If I say you have to find five numbers between them, let's say you have to find five numbers between them. So what you will do, again 2 and 3, 2 by 1, 3 by 1, multiply it by 6. As 5, take 1 extra, 6. Generally you people do multiply by 10. You'll get maximum only, but here I'm telling one more way, that you take, if it is 5, take 1 extra only. So into 6, what will it become? It is 12 by 6, and this is 18 by 6. So from here you have 13 by 6, you have 14 by 6, 15 by 6, 17 by 6. 13, 14, 15, 16 I missed. Yeah, so let me write 16 by 6 and 17 by 6. So you got five numbers, irrational numbers between these two, 2 and 3. Let's take a number which is fraction form. Okay, so let's take one more which is in fraction form. Let's insert five rational numbers between 3 by 5 and 4 by 5. Now it is what? You have 3 by 5, 4 by 5. One way I told you, find the average of the two, then again average of the this one and the middle one, then average of these two, and then keep on going. The easier way is what? Easier way is make them like fraction. They're already like fraction. Now you have to find how many? Five rational numbers. So take one number which is bigger than the 5, that is 6. So multiply both the numerator and denominator by 6. So what you will get 18 by 30, and here you got 24 by 30. In between you have now 19 by 30, 20 by 30, 21 by 30, 22 by 30, and 23 by 30. You have 1, 2, 3, 4, 5. 5 rational numbers between them. Clear? Here in this case, they were already like fractions. Sometimes you will get fractions which are not like. Let's take an example. You need to insert between 2 by 7 and let's say I'll take 3 by 5. You need to insert, let's say 5, insert 5 rational numbers between them. Okay, so now if I have to insert 5 rational numbers, I have to first make them like. Make fractions like. How can I make them like? LCM of 7 and 4, that is 35 only. So what I have to do is multiply it by 5. This also multiplied by 5. This I'll multiply by 7. So what I got over here, this is 10 by 35 and this is 21 by 35. Here, I don't think I have to do anything else. There already you can see you have so many numbers between them. So you can take any of them. 11 by 35. You can take 13 by 35. That is also in between that. You can take 15 by 35, 16 by 35, 20 by 35. There are many in between. From here 11 to 20 you can write any of the number. So you got it. But sometimes let's say if after doing it you do not get it in this long way, then you take multiplied by 6 both numerator denominator in the both side and then find more. Clear? I hope till here it is clear. We have done different type of numbers. We talked about real numbers which include rational and irrational. Then rational numbers, I said they can be natural numbers, they include whole numbers. Not rational can be natural numbers. Rational numbers include all natural numbers, whole numbers, integers. And then we talked about the decimal expansion of rational numbers. Rational numbers have either terminating decimal expansion or non-terminating but recurring decimal expansion. Irrational numbers, they always have non-terminating, non-recurring decimal expansion. So this was the topic for today. I hope it is clear.